we start now developing our game. As discussed last time in class, whenever we use the Pygame package, we kind of start from a skeleton, from a piece of boilerplate code that needs to be used every time the Pygame package is used. So let's revise very quickly what this boilerplate is like. It is what you see currently on the screen. We import the Pygame package, and this package contains a bunch of sub-packages, and from those sub-packages we import a bunch of other things, right? We import the locals and we import the constant quit. Later we'll see that we might want to import other constants. These are key presses or events, names of events that may be useful for us. As before, because we want to quit the game at some point, we import the module sys. And then we know for sure, because we have to do a lot of geometric things, we're going to need some math functions. And because we want to allow it's a game, right? You have to have a bit of unpredictable stuff. We're going to import the random module. As before, the game is played in a window of 800 pixels by 600. It's a typical thing to create a screen rectangle out of this window size, initialize the Pygame set, initialize the keyboard. So we want to be able to use the keyboard to direct the sprites, the widgets of the game, and we need a fast repeat rate, which is what we're setting here. We set the color mode to the best through 32-bit depth. All right, we do that in 2 steps. We make sure that this depth exists. We are trying to verify with mode OK whether a 32-bit depth exists, and then we create a screen object. This screen object is what will allow us to perform a lot of operations. This screen is created by also setting the color mode of the package. We give a name to the window in which the game is played, and the game is asteroids. This will also tell you a little bit of what we're going to be building. If you want to know the rules, Google it. Obviously there are many variants. We're going to build a relatively simple one just for demonstration purposes. We also need a clock objects to be able to throttle the frame rate at which events are being updated on the screen. We don't want to push that too high. Inside the while loop, so the entire game is in a while loop where new renderings of the current state are being displayed in sequence, right? So we display one screen, one frame, we allow it to be there for a while on the screen, right? And we change to the next one and then to the next one, right? So we build the next frame and display it, we bring the next frame and display it, right? And this happens in a loop that is potentially infinite, right? We don't have to leave it at any point. Part of this loop is dealing with events that happen from the peripherals of the computer. The main peripherals are the keyboard and the mouse, and if the event receives the quit, the game receives or the package receives the event called quit, which is essentially the event produced by closing the window, clicking on the X right here. If that's the case, then we want to quit. We similarly want to do that whenever the escape key on the keyboard is being pressed down, right? So we have an event generated by the escape key, and specifically we want it to happen when that key is being pressed down. We're going to have 2 events, one of pressing the key down, the other of releasing the key. So at that point we have to quit. The quitting of the program has to be done after quitting the package. So the package will have to restore the state of the graphics card, or have to restore certain things on the graphics card, and it is not advisable to quit the game without invoking pygame.quit. All right, so this is all an entire protocol. We have to respect it. We don't have to understand very deeply what happens there. Finally, we can quit the Python program, right? This is the function that does, right? In here, in this space, where I'm going to add a few commands, in this space, we're going to write our own game logic. And at the bottom of the screen, we have to, and in that logic, we're going to build the frame that is about to be displayed. Now, once that frame has been built, this invocation, display.update, will take that frame and put it on the screen. Fill the window with that frame. And finally, we add this call that throttles the number of updates, right? It limits it to whatever number we put here, 60 per second, no more than 60 per second. 30 is probably a number that is good enough. Most games don't play above a frame rate of 30. That's actually because the game logic is so complicated that it takes a lot of time to build a frame, right? This is not going to be our case. But I am on a machine where the graphics card is not very high performance, and also at the same time there's a video recording happening, which takes some capabilities from the graphics card, so I don't want to push it too hard, too high. There's another thing that we have to do inside the inside this loop, which is screen.fill. We have to wipe the previous frame before building the next, right? So I have to do a screen.fill with a color, right? The wiping is essentially filling the screen with a color, and I'm going to pick black. Black means all the colors are at the least brightest, which means that we're filling it with zeros. Notice that a color in general is a tuple, a triple, right? A tuple with 3 components, right? So we need 2 levels of brackets here in order to make sure that a single color is being passed into the fill. So this is the skeleton that we have. I'm going to save, and right now we can very nicely do python game.py, and we can see the game opening. It's a empty window for the time being. If I press escape key, it quits. All right, this is what the skeleton is doing. So we're going to start with drawing a ship. All right, so and we're going to be very minimalistic here. How do I draw a ship? Well, the ship has kind of the shape of a triangle, so I'm just going to use a triangle. So in general, the ship is going to have a shape like this. Now, well, unfortunately, I'm not very good at drawing. I'm going to try to make it isosceles. The 2 sides, this one and this one, should be equal, right? And we will say that the center of the ship is here. All right, so now when we do that, one important thing is how are we going to maneuver the ship? We're going to maneuver the ship by having thrust. So whenever we press the up arrow, the ship is going to thrust forward in whatever direction is pointing. And we're going to use the left and right arrow to rotate the ship, right? So in other words, if the ship is facing like this, right, it will go in this direction, right? If it is facing like this, it will go in this direction. So what will rotate the ship is leftwards and rightwards is essentially the left and the right arrows. I would like to draw arrows here, but I am not very proficient at doing that. We're going to say that there's a center. There's a center. Somewhere here, and then how do we draw the ship, right? Because we want to rotate the ship. The important thing is to always control the drawing by angles. All right, so I'm going to pick a center, and then I'm going to pick 3 points at certain angles from that center, right? So I'm going to pick an angle here, and the question is, what would be a good angle here? What would be good angles, right? And maybe I'll pick something like, let's say 150 degrees. 150 on one side, 150. I don't know why this doesn't work. I think it's because of its conflicts with the recording. 150 on this side. This is awful, right? And I will join these points. All right, so there will be a center. There will be these 3 points at equal distance from the center, but at different points, right? So the shape of the ship is going to be sort of an isosceles triangle. Now, because I have everything at an angle, if I need to draw the ship at a different angle, at a different orientation, say like this, all I have to do is offset the drawing angles, right? That 150 is going to be 150 plus or minus an alpha, right? So if I want to draw it like this, right? Starting from, we're actually going to start from a horizontal angle, right? So I'm going to put this on alpha. This is going to be alpha. And then this angle here is going to be alpha plus 150 degrees. Here is going to be alpha plus alpha minus 150 degrees, right? And then we can find the 3 points. That will make the ship very easy to rotate. So let's get to it. So we're going to start with a procedure called draw ship, right? And the ship is going to be drawn at a certain position. All right, so I'm going to say pause. The position is going to be a tuple of 2 coordinates, an x and an y, right? And the other thing is an alpha angle. Let's call it just angle. So this is the orientation. And later we're going to see that if the ship is moving, we might want to show thrust. But let's leave it for later. Let's leave that for later. We want a certain radius, right, for the ship, right, from the center to each of the 3 vertices of the ship. We want a certain radius, and let's say that the radius is 30. We can change it later, right? And we want a certain angle between the radii corresponding to the vertices, right? We were saying that it's about 150 degrees. let's call that angle alpha, right, which is going to be 150 degrees. 150 degrees is, we can't work in degrees, we have to work in radians. So let me very quickly can I go here and get a calculator? Right, so 150 divided by 180, which is pi, we have 0.83. 15 divided by 8. So this is 5 divided by 6, right? 5 divided by 6. So 5/6 of pi. All right, so let's do just that. So alpha is 5 times pi divided by 6. We have imported pi right here, so it's all fine. And then, right, remember we have an angle, which is this one given here. So we're going to have 3 vertices. I'm going to call them x1, y1, x2, y2, and x3, y3, right? So from the center, which is that position, right, I have a center. I have the coordinates of the center, which is xy equals, and this is very interesting way of taking out the components of a tuple. Xy equals pos. All right, so then I can say x1, so this is the tip, should be x plus radius times, so let's see how this works. So we have a system of coordinates, right? We have a center, all right, and we want to draw this shape, something like this, right? So the first radius is this one, right? And we want to find this point, this vertex, all right? So we have the coordinates xy here, and here we want to have x1 and y1. All right, so this angle is alpha, right? So obviously x1 is going to be x plus radius times cos alpha. And this thing just doesn't want to write, man. It's incredible. Cos alpha, right? I'll just alpha. And then similarly, y1 equals y plus radius times sine alpha. All right. Now, when I'm going to have to compute this guy, the angle alpha is going to be, well, when I say alpha here, this is actually angle. This is not alpha, this is angle. Right? So when I have to go to this, I'm going to have angle plus alpha. When I have to go to here, it's going to be angle minus alpha. Right? So this will, in principle, sort things out, right? So I'm going to have x equals x plus x1 equals x plus radius times cos angle, right? y1 equals y plus radius times sine angle. x2 equals x plus radius times cos angle plus alpha. y2 equals y plus radius times sine angle plus alpha, and x3 equals x plus radius times cos angle minus alpha, y3 equals y plus radius times sine angle minus alpha. And we have to draw now lines. So there is a package procedure, a procedure inside the package that draws lines. Pygame dot draw dot line, and what we have to give here is the screen object, right? The screen represents the window. We could have multiple screens at the same time. I mean, multiple windows, Pygame windows open on the screen, right? And we might want to draw in either of them, right? So specifying which one is important, right? So what I'm trying to say is that we could have created multiple windows. This screen here, we can have screen 1, screen 2, screen 3. It means with 3 objects, we have 3 Pygame windows on the screen. And then we might want to draw in either of them. So we have to say which one of them do we want to use. Then we have to provide a color, right? So I'm going to say ship color, and I'm going to make it red. So ship color equals red, which is 25500. Of course, we can change it later. Ship color, and then we have a start and an end. So the start will be x1, y1, and we have an end x2, y2, and we have a thickness, and we're going to pick the thickness of 2 pixels thickness, right? And this is one side of the ship. The ship has 3 sides, so we're going to have 2 more. So we're going to go from x1 to x3, and from x3 to x2. All right, and this draws the ship at this orientation. All right, so one thing that we can try now is to see the ship rotating on the screen. Does this work? All right. So we're going to start with a global angle of 0. Ship angle equals 0, and then we're going to want it to rotate. And then we're going to say at the central coordinates of the screen, which are 400 and 300, right? We're going to say draw ship at 400 and with an angle of ship angle, and then we want ship angle to increase by pi divided by, let's say, 30. All right. So every frame we rotate the ship by pi over 30. We save, and let's run and see what we get. Okay, so there you go. We have the ship, and it's rotating at the given speed. All right. Maybe the ship could be a bit bigger, and the frame could be a bit thicker. So I'm going to increase the thickness to 3. And I am going to increase the radius to 40. Okay, let's see again what's going on here. All right. Maybe the ship can be a bit fatter. So instead of an angle of 5p divided by 6, let's do a 4 pi divided by 5. Let's see if that suits us better. Okay, maybe this is better. The next thing we want to do is to have the ship angle being controlled by the keyboard, right? So currently the ship angle gets changed automatically. We can't control it from the keyboard. So let's try to do that. All right. So we're going to need new events. All right, so we're going to need new events. So right here in the event loop, we're going to say else, if, right? This is, right, if we haven't pressed the quit event. So if this was not true, which means that the key event was not pressed, well, maybe there's some other event that has come in, right, that we're waiting for. So we already know how to wait for a key down event, for a key being pressed event, right? So we're going to say event dot type equal key down, and event dot key equals pygame dot, and the left key is k underscore left. All right, and if that's the case, all right, if that's the case, we have to change the angle so that it moves to the left. So that's decreasing the angle, right? So we're going to have, say, ship angle minus equals pi divided by 30. All right, elif event.type equals key down, and event.key key right. We're going to have ship angle plus equals pi divided by 30. Okay, we don't need the automatic change anymore. All right, and now, because of this, we will be controlling the ship with the keyboard. So let's test again. So now the ship is not moving anymore because we don't have an automatic movement. And I'm trying to center the window. But notice that as I press the left arrow, right, it's moving to the left. As I press the right arrow is moving to the right. I can do continuous key presses because I have set the keyboard to have a very high rate of repeats, right? And that allows the movement to appear almost continuous. So again, pressing on the left, pressing on the right. If you press both, the one that appears first in the test is the one that prevails. right? So we are checking for movement to the left. So if we press both keys at the same time, this is the one that prevails because this is true, and we never get to check this one. Yes? Okay, cool. The other thing that we want is, from this point on, to have thrust. So we want to press on the forward, the up arrow, right? The up arrow, elif, and have thrust. Equal K key down, and event dot key equal pi game key dot key underscore up. All right, and so first of all, let's just get it to move. All right, so we're going to have a notion of velocity, which let's say is 10 pixels, right? But we have to move in the direction of the angle, right? So we're going to change the position, right? So another thing that we don't want to keep constant is this position right here. This position is a constant, right? So we're going to have a ship position and then this is the ship position, and we're going to change the ship position inside the loop. All right, so the position XY can be obtained from the ship position like this. All right, and then the new position, which is going to be x1 and y1, right? So x1 is going to be x plus velocity, ship velocity, times. So remember always, x is cos and y is sine. So cos of ship angle, and then x2, y1 equals y plus ship velocity times sine ship angle, and then we're going to say ship position equals x1 y1, right? We update it to the new position. And then when we're going to press the up arrow, the ship is going to move forward. So let's see that this is possible indeed. So we have the ship, and you see that as I press the up arrow, the ship moves in the position, in the direction, of the arrow. The domain, the landscape of the game is infinite, and you can consider the current window just a viewport in that landscape, right? Meaning that you can send the ship anywhere, and it will stay at that position even though it's invisible. And then if you know what you're doing, right, you can move it around and bring it back at some point, right? So whenever the coordinates that where we draw at are visible, the ship will be visible, right? You can see that we can have partial visibility as well. We can just rotate it and move it in a different direction. Now, one interesting thing that we typically want in games, because we don't want this situation where the ship just disappears, is we want wraparound. So meaning that when the ship exits the window on the right, it re-enters it on the left, and vice versa, right, from left to the right. and the same with up and down. So let's implement that and have a ship that never leaves the visible area of the screen. All right, so we can have a very simple test here, right? So if if x1, which is the new position, is greater than width, right? We can wrap x1 around. x1 becomes x1 minus equal width. All right. And if x1 is smaller than 0, we can say x1 plus equals width. And similarly for y1, if y1 is greater than height, remember height is measured downwards, meaning that it's below, the ship is below the window, then we're going to do y1 minus equals height, meaning that we're subtracting height from y1. And if y1 less than 0, we're going to do y1 plus equal height. And remember that the width and the height are the width of the height of the window. They were defined right here. All right. So back to the place where we just finished the editing. All right. So we just added this part. And okay, now the ship will re-enter on the other side. So let's make it more like, all right, on a diagonal, so it looks like it's really wrapping around. Now, at this point, I am keeping my finger on the up arrow. As long as I keep the finger down, keep the keyboard key down, the ship moves, otherwise it doesn't. The one interesting thing that we would like to do is to have the ship have acceleration rather than velocity, just velocity, right? So when we press the up arrow, we are actually giving the ship acceleration, and the speed will keep increasing and increasing and increasing up to a maximum speed. And then when we take our finger off the key, we would like friction to act and slow the ship down. Obviously, there's no friction in space, so we're taking a little bit of a creative bend here. We're going on a creative bend. Nevertheless, it will be an interesting thing to model, right? So instead of having ship velocity, I'm going to have ship besides having ship velocity, I'm going to have ship acceleration, right? So the acceleration will increase the velocity, and the ship velocity is no longer constant, right? So I'm going to start the ship velocity at 0, right? Ship acceleration. And here we have to pick a value, and maybe 3. 3 is actually very, very high. So 0.3. I'm gonna give it, right, because it's every 30th of a second the velocity increases, right? And I'm gonna have the ship velocity as a real number rather than integer. All right. So if any, I have an event type of key down, of key up, right? So this is the acceleration. So the first thing that I'm going to do is take increase the ship velocity by the acceleration, right? So I'm going to say ship velocity plus equals ship acceleration. All right, ship acceleration. All right, now if there's automatically there's friction, right? So at the top level inside the loop, we're going to automatically apply friction. So let's define here a value for the friction. Ship friction, and then this should be smaller than the acceleration, right? So I'm going to make it 0.05. All right, and I'm going to deduct the friction from the velocities. I'm going to have, say, ship velocity, and actually I'm going to do that after having drawn the ship. So I'm going to go here, draw the ship. I'm going to have ship velocity minus equal ship friction. All right, and let's see what happens now, right? So write a game. So as I keep pressing, you can see it accelerating slowly, but so one thing that I just did was to take this block. All right, so this block, let me just go again back where it was. Right, so it was here. So this block has to be at the top level of the loop. Notice, however, that the top level of the loop is here, aligned with the for and not with the if. So in order to do that, I'm going to select this block, and I'm going to press Shift Tab twice. 1, 2, right? So now notice that the block is aligned with the for loop, right? So this is stuff that has to happen all the time, right? Not only when the down key is pressed. When we have a down key up, we apply acceleration, right? But as long as the velocity is non-negative, the ship has to keep moving. I'm going to put some spacing here to make it clear that this is part of the main loop, right? And this is the ship moving inertially, right? Ship moves inertially, right? So we have some velocity. As long as the velocity is not negative, right, because we have applied some acceleration, we have the ship moving forward. Now, once we have finished drawing, we want to apply friction. However, friction should only apply as long as the ship moves forward. So if the ship velocity becomes negative, we should protect the state of non-moving state of the ship, right? So if ship velocity is smaller than 0, then we should set to 0. All right, so if we run now the game, yes, including this line. So I'm going to do a Shift tab here as well, and I'm going to take this line and move it. Control S. All right, let's run now. And now the ship, I keep pressing. While I keep pressing, you can see that the ship starts moving faster and faster. Now I release, and then while I have released, the ship moves forward inertially while friction acts on it to slow it down. And you can see how it slowly slows down. I can steer the vehicle, the ship, with the left and right arrows, right? And again, I can get it to have some acceleration. Now it's moving inertially, and I can steer it around with the all right. Okay. Now the interesting thing that so this adds an extra level of difficulty, right? Because when we add asteroids and we add collisions, it makes it more difficult to avoid the collisions. So the next thing that we like to add is thrust, like the visibility of thrust. Now, whenever we apply acceleration, obviously that is thrust. The ship has thrust, but we would like to make the thrust visible, right? So let's see how we can do that. So we are going to, in the draw ship, we are going to add a truth value here, which is called show thrust. So this can be true or false. And if it's true, not thrust, thrust. If it's true, we would like to show thrust. How do we show thrust? Well, we're going to be very practical in general, right? It's very difficult to do something overly realistic, but nevertheless, we can show some kind of colored stuff behind the ship, right? So that color stuff is going to be little circles of various sizes and various colors, right? Appearing for just one frame in random order. So this will give the feeling of a flame being burning, or flame burning there, right? So let's say we're going to show something like 10 circles. So we want 10 of them. And then those circles would be of various size, of random size, random color. So we're going to have a radius of so we have a radius. So there's going to be a distance let's say at maybe up to 20 pixels behind, right? So we're going to have the radius plus up to 20, right? So we're going to say 20 times random. So this will give us a value between 0 and 20. So this is the distance behind the asteroid, right? It has to be at least a distance equals to this radius here, right? Because otherwise it wouldn't be behind, right? And it has to be sort of randomly placed. We are going to have a random color. So it's going to be color, and the color has to be a triple, right? And each of the three components is going to be a random value, right? But we don't want a random value between 0 and 255 because that's too wide a range. We want a relatively small range between 120 and 255. right? So 135 times random. So since random is a value between 0 and 1, right, 120 plus 135 times random is at the lowest random can be 0, so we have a value of 120. At the highest random can be 1, so we have a value of 255, right? And each of the components of the color is random. All right, so this is the color. And then, so we are in a loop that will draw 10 circles. So let's draw the circle. In order to draw the circle, we're going to need a center and a radius. Both of them are going to be random, right? So the angle has to be between, so we define this angle to be 4 times pi over 5, right? So it can only be between pi minus pi minus pi over 5 and pi plus pi over 5, right? That would be the range there. All right, so let's see. So we're going to have an angle. Let's call the angle A. So that angle we already have used is a pi. So it's actually alpha. So it's actually, wait, it's angle plus alpha plus, and we have angle minus alpha 2 times pi minus alpha times random, I think. All right, so now with this A, let's have an x thrust equals x plus this r times cos of A, and y thrust equals y plus radius times sine A. And finally we can draw the circle. So we have pi game dot draw dot circle. And for the circle, again we need to say the screen, which window do we draw it on. We have a color that we have just defined, and we have the coordinates. So these coordinates have to be integers though, so we're going to turn them into integers on the fly, xt, and then they have to come as a tuple. Sorry. And then the next thing that we need is the radius. And we're going to make the radius also random, but an integer between 0 and 5. So floor of 5 times random. Now, so we have an asteroid, a ship, which can show thrust, right? So we're going to have a condition variable, a flag, equals false here, and then if we have acceleration, then we're saying show thrust equals true. Okay, and then at the time of drawing this show thrust is going to be passed in here, and then we should have thrust. Okay, so let's see how this works. All right, so this is, so now you can see essentially when I'm pressing the button and the thrust button, the up arrow, and when I'm not doing that, okay, so probably the 20 pixels that I considered as the length of the thrust is too little, right? So I gave a value of 20 here. So this probably is better to have a value of 40. Also, the angle is a bit too wide. All right, so this A angle is a bit too wide. So let's restrict it a little bit. So I'm going to say 1.2 times alpha here, and pi minus 1.2 times alpha, right? So this will reduce the alpha at the end with 20%. Maybe actually I could do even 30%. So let's see again what we get. Okay, so maybe this looks a little bit more like a real rocket engine. All right. Now this is a very customized version of asteroids. If you play the real version, you'll see that the inertia actually obeys the laws of physics. So once you don't have, you stop the thrust, the ship keeps moving in a linear direction. It keeps the same direction of movement even though you turn it around. Here we can actually steer it like it was a car. All right, so it might be part of your homework to fix that. All right, so we have a ship. We are pretty much done with the ship. I think here I can say underscore if I don't use it, because I'm not using I at all. Does this work? Yes. All right. So this is the ship. All right. The ship is controlled by its position, its angle, right? The ship rendering, essentially, right? And whether we show the thrust of the ship or not, right? Internally, we have certain constants that decide the geometry of the ship, right? The ship is an isosceles triangle, has three vertices. We compute the coordinates in this way, and we just join the vertices, right, to give the appearance of a ship. If we have thrust, we draw 10 random circles behind the ship at random positions, but in a very confined space. All right, and of random colors and random radii, but again, the ranges are very well controlled, so that it sort of gives the appearance of a flame jetting out of the ship. All right, so I'm going to stop the first recording here. The next recording will, in the next recording, we're going to deal with missiles. So let's continue on with giving giving the ship missiles, right? The ability to shoot missiles. So the missile is another moving object, and it moves completely independently once it has left the ship. It will continue its direction undisturbed. We're going to write a procedure to draw a missile. And the missile will have a position and will have a direction, which is an angle as well, right? The angle of movement. Missiles will move at a constant speed, which we will pick, all right? And we'll actually, in drawing the missile, I don't need to know the angle. It's just a circle. So draw a missile at a position. That's all we need. And what we will do is essentially Pygame the draw circle, right? So we have to draw it on a given screen, which is our screen, and we have to pick a color. And let's say the color is green. We're going to do missile color equals 0, 2550, and then we're going to put missile color here. And then what else do we want? We want the position, and we want a radius, and the radius should be very small, something like I don't know, 4 pixels should be sufficient. Okay, now one thing that we need to keep track of during the game is the set of missiles that are currently in movement on the screen. So, which means that the ship can shoot a new missile while one is already moving on the screen, right? So we don't know how many missiles we're going to have at one time on the screen, right? We don't know in advance. It may be 5, it may be 10, it may be 1, it may be 0, right? And we need to keep track of them. So we're going to use a list, which is initially empty, there's no missiles, which contains all the missiles. What is a missile? Well, the missile has a position, a current position, but it moves, so it has a certain direction of movement. The speed at which missiles move is constant, right? And we're going to put it here, missile speed or velocity, and we're going to make it quite fast. So let's say it's something like 5 pixels. 5 pixels per frame is too much. 3 pixels per frame should be fine, right? So inside the missiles list, we're going to have pairs of position and direction and angle, right? The position is going to be a tuple itself, so it's going to be a tuple containing another tuple and an angle. So one thing we have to do after we draw the ship is to draw all the missiles. All right. So here we're done with drawing the ship. So I'm going to say for missiles in missiles, right? For each missile we draw it, and immediately after that we have to update its position. All right. So in order to update, we're going to start with a new list called new missiles, which is initially empty. So we read from old missiles and we update the position and we'll put it in the new missiles. All right. So what we have is that we have a position and a direction, which is an angle, being the missile, right? Actually, we can do this right here. So we can say position and direction, right? And then the position is an x and y. So x and y equals the position, right? So we now have the x and y. Now the new position x1 is going to be x plus missile velocity times cos direction. Y1 is y time, plus missile velocity times sine direction. All right. And then the direction never changes for the current missiles, only the position changes. For the current missile, yeah, only the position changes. The direction stays always the same for the any given missile. But we only place this missile on the screen. It will only draw this missile if it appears on the screen, right? So if 0 less than x1, which is also less than width, right? And for equals, for 0 we can say equals, right? So every interval is inclusive at the left and exclusive at the right, as discussed before. Less than equal y1 less than height. Right, if this happens, it means that the missile is on the screen and we have to draw it, right? So we're going to say draw missile, and we're going to say the position, which is x1, y1, all right? And then we can add the new missiles we can add the new position to the new missiles. All right. So we do that for every missile, and at the end, once we have collected all the missiles that are still on the screen, we can update the missiles to be the new missiles. All right, so this is the drawing. Now, how do we shoot every missile? Because this is drawing missiles that have already been shot, but it doesn't tell us how to shoot missiles. Well, let's choose another event for another keyboard event, another key for shooting, which is maybe the space key. So we're going to have here elif event dot type equal key down and event dot key equal pygame dot k space. So if this happens, we want to extend the current set of missiles by 1. So we're going to say missiles dot append, and what do we get? What do we put here? Well, we should put the tip of the ship, right? We should put the tip of the ship. So going here, right, we have the radius, we have the position of the ship, which is ship position, right? We have the ship radius, which is inside here, and then based on that, and we have the ship angle, right? And based on that, we can compute the place for the missile. So we're going to have ship position 0. So this is going to be the x, right? Plus ship radius, which is 40, times cos of ship angle, right? And the other thing is ship is the y coordinate. Ship position 1 plus the same 40 times sine ship angle. All right, so this will put a new missile in the set of missiles to be drawn. All right, so now let's see what happens. I'm not quite sure what happened here. Something bad happened. I think I just opened a new window. If I go back here, I will just get what I want. I have an error. We're in line 49. Oh, so here I have I have an extra bracket. Okay, let's go here, this, and now, oops. So at line 101, for PD in missiles, I can't say PD in brackets. It has to be outside brackets. Why is... All right, so let's debug a little bit. Right, so I have a that is very true, because here I need not just the position. So I'm appending a position and the ship angle. So let's make this even more obvious what it is. So it is a position and an angle. So now it's very clear. Right, so this object is the spec of a missile. The spec of a missile is a position, which is a pair, an x and an y, and an angle, which is the same as the ship angle at the time of shooting. So now we can try this, and unfortunately circle needs integer arguments, so we need here to say floor and floor. It's a bit of a letdown because so let's make it even more obvious. Because line drawing works very fine with non-integers, with floating point numbers, whereas the circle doesn't. So we have to explicitly convert into floor. Again, in line 49, have I saved here? Maybe it's the colors as well. Oh no, this is definitely not the colors. This has worked fine. Maybe int. We also have to do this here. So int and the same here. We have to pack it with the direction. So the direction is D. So this is way too slow for a missile. All right, let's remove the printing here that we used to use for debugging, and let's increase the speed, the velocity. So the velocity should probably be something like 10. Okay, so this is much better. These are our missiles. All right. So you see, because of the key repetition, we are shooting missiles at a very high speed. Right. Normally, what we would want is to wait for the key release before we allow another missile to go. But for time being, let's leave it as it is. All right, so we are going to stop the second recording here, and next we're going to look at asteroids. So the next thing that, before we go any further, actually, let's recap a little bit everything we've done, right? So we have two main concepts implemented. One is that of a ship, and the other one is that of a missile. All right. We have a single instance of a ship, but nevertheless, we can have multiple instances of missiles being active at the same time. So therefore, we can have a set of global variables for our ship, but nevertheless, we need to have a collection of missiles um, stored in a global variable. All right, the pattern is very standard, right? So we have a place in this loop where we check for events, right? Each event changes the state. The state is controlled by a number of variables, such as, right, the ship angle, the ship velocity, right, the show thrust, and the set of missiles. And then whenever an event occurs, right, one of these variables changes. Then, based on these variables, we render graphically the canvas of the game, right? So we literally draw on the screen, all right? We literally draw how that state looks on the screen. And potentially, if there is further updates to be made to the state, we do that, right? After this process, right? So one thing that we need to do, for instance, if even if there are no events, if the state has velocity, right? That velocity doesn't go to zero immediately, right? So because of friction, it needs to be reduced slowly to zero. And how does that happen? It happens here, right? So there are parts of the transition that are not just dependent on events, but also dependent on the physics of the game. We have used two procedures, draw ship and draw missile, all right, to render on the screen the ship and the missiles, right? And then notice that for the missiles, all right, we perform the rendering of all the missiles in a loop, right? So for all the missiles in the list of missiles, we perform a rendering. Next, the next thing that we want to do is draw asteroids. All right. So for asteroids, we want to sort of make them look as a rock. And the way we're going to be able to do that is the following. We're going to use two imaginary concentric circles, which I draw with yellow color. And I'm going to try to be as close to a circle as I can. And I'm going to draw them kind of large. In reality, they're not going to be this large. And kind of far from each other, though they're not going to be that far from each other. And then, right, we're going to start from the angle of 0. So there's this angle of 0 here, right? And we're going to pick a dot on one of the circles, let's say the small one, all right? And we're going to start producing random angles in a certain number, let's say 15 or 10 of them. Actually, I'm going to pick 5 on the drawing just because it's easier, but in reality, we'll pick maybe 10 or 15, right? So I'm going to pick 5 angles. So this will be 1, and they will be completely random. And we'll see how that can be done, right? So the angle from origin to here is going to be random, right? There's another one here, and this angle is also going to be random. But I'm going to make sure that all these random numbers will produce 5 angles. So 1, 2, 3, 4, 5. Let's see. Is 5 good enough or not? And then all these things that we're actually not going to draw, they're imaginary, right? But it's important for us to give guidelines. So then I'm going to identify all these points. So 1 point here, 1 point, another point here, another point here, then another point here. And notice how I alternate on the circles, right? So I start from the small circle, I go to the large, then I go to the small, then the next one on the large, then the next one on the small. Yeah, here. And then the next one on the large. And then I'm going to join these lines. I'm going to go here, 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 here. So this is going to look kind of like a rock. In reality, if we pick instead of just 5, something like 15 points, we're going to see something like this. Right, a circular shape, but with a very irregular edge. Yeah, so it kind of looks like an asteroid. And this is how we generate it, right? All the asteroids should look different from each other, and because of the randomness of the angles, that irregularity is, and that non-identity between asteroids is accomplished. All right, and then obviously we want to have as many asteroids as we can. We don't want to set on like 2 or 3, or we want the number to be variable, and decide on the policy on how we generate asteroids and how many of them there should be in the game. We want to do that separately. So we are going to start working on drawing an asteroid. All right, and let us do that. All right, so we're going to create a procedure called create asteroid first. So after draw missiles, we're going to say right, and this Asteroid creation, essentially, what is an asteroid, right? So now an asteroid is a relatively complicated object because it has all these angles, right? All these angles are part of the spec. Um, and um, we have to create something like that. We want to create an asteroid based on a position and in principle we want the asteroid to be um, essentially at a um, just give me a second. So we want to create an asteroid and we want to return a list of essentially angles. This is the most important thing that we are creating, right? An asteroid um, should remain um, fixed in shape during once it has been created, right? Um, so I'm going to create an angle, a set of angles, as in a very simple fashion, right? Um, we're creating angles from 0 to 2 times pi, right? So I'm going to create them randomly 2 times pi times I, where I is random, right? And I'm going to divide this by 100. Um, all right. And we're going to take an advantage of some um, samples. So 2 times pi times I for I in sorted um, sample range. So we're going to go from 1 to 100. I doesn't quite count. But we don't want an I that can be 0, right? So we're going to say 33 here, so 1/3 of 100. All right. So we have a set of angles now. Then we're going to create the asteroid besides the um, besides the angles, right? We are going to create it with a. We want them to slowly rotate as they move around, right? But we're going to want the movement to be quite straightforward, so they move in straight lines, right? So we have to set a direction for movement, and it has to have an initial position. The initial position of the asteroid has to be completely random as well, right? So we're going to say pos x to be floor. And remember that whenever we work with circles, we want the numbers to be integers, right? With random numbers are not integers, so we have to convert them. Random pos y is floor of height times random, and We're going to try another thing. We're going to try another thing. We're going to try to place um, the asteroid not too close to the to the ship. So I'll tell you what, we're going to put here the position of the ship, and then we're going to try to avoid being too close from the ship. So guess what? We're going to try 100 times to stay far away from the ship. And then after 100 times, we get whatever we get, right? So while typically we would get it very quickly, right? Because random numbers are quite good at generating a large variety of numbers. So we're going to end up probably quite quickly getting a random position that is not very close from the ship. We're going to say that it's not too close of the ship if the x-coordinate, if both the x-coordinate and the y-coordinate are less than 100 pixels away from the ship. So assuming that this P is the ship position, actually let's make this a bit more clear, right? Ship position. So this ship position is something we want to avoid. So if apps of pos x minus ship position 0, 0 will be the x-axis, right? So actually let's put the xy equals ship position, because this makes it a lot easier. So if pos x minus x is less than 100, or abs pos y minus y is less than 100, all right, it means that we're too close. If either of these is true, it's too close. So what do? We generate the same number again. So we're going to go and try again exactly the same instructions, right? In this way, the game is not too dull, because if the asteroid is placed stupidly exactly at the same position with the asteroid, there will be immediately a collision and the game will stop, right? And we will generally find that unfair. So we want the asteroids to somehow be placed not very close to their initial position, to be not very close to the ship. Now, these asteroids need to have a speed. So there's going to be a speed, and the maximum speed is going to be very slow. We don't want to make them too fast. So at most 2, right? We're fine with the speed being actually 0. And we have to have a direction. So the direction is any angle between 0 and 2 pi. So it's 2 times pi times random. All right, and the entire spec of an asteroid is an entire tuple here, right? So we want the position, which is pos x, pos y, and then we want, initially the rotation angle is going to be 0, but this rotation angle is going to be increasing slowly. All right, then we're going to have the angles which allow us to render, and then we're going to have the velocity, and then we'll have the direction. Right, so all these elements are part of a asteroid, right? So this is the data structure, the data corresponding to an asteroid, and this is not enough actually. There's another important thing that needs to be done, which is we need to render, right? So we'll have a procedure called def draw asteroid, AST, right? AST is a tuple like this. This is what comes in, right? And we're actually going to say that pos, right, rotation angle, right, angles v and direction velocity equals AST. It's amazing. All right. And then we have to draw the asteroid. Okay, so let's see what happens in drawing the asteroid. All right, so we have to draw lines for all the angles, right? And then for each angle, we have to compute the corresponding point. So we're going to have a loop for I in range of 0 to len angles -1. And then if the I is 0, we're going to go on the inner circle, right? And if I is even, sorry, if I is odd, we're going to go on the inner circle and otherwise on the outer circle, right? Then each of these circles needs to have a radius. So we're going to have radius bin, which is, I'm going to say, something like maybe 40, 40, and air max, which is 50, right? The outer one is 50. So if I %2 equals 0, right? Because we have to alternate. So whenever I is even, right, we're going to use the first, we're going to go from the inner circle to the outer circle, right? So we're going to use the current point on the current angle on the inner circle and next angle on the outer circle. And then if I is odd, we're going to go in the opposite direction, right? So we're going to have that x0 equals, so let's call x and y equals pos to make things easier. So we're going to have x0 equals x plus r min times cos. And then we're going to take the angle of angles I. And obviously everything has to go with the rotation rot. So plus ROT. Alright, cos angles plus the rotation rod. And then y0 is going to be x plus r min times sine angles I plus rod. Yeah. So I got this one wrong. Okay, and then x1 is going to be x plus r max times cos. And now I'm going to take the next angle, angles I plus 1. Yes, plus rod y1 equals x plus y plus. And the same here, this is y. Times sine angles. All right. Else. So else, we're going to alternate our min and our max. So I'm going to take Control C, Control V, and wherever I have our min, I'm going to use our max. And wherever I have our max, I'm going to change it to our min. All right, so now what's left to do is draw a little segment by game dot draw dot line on our screen, right, with a color, say yellow. So I'm going to use 0, 2, 5, 5, 2, 5, 5. Let's make it more explicit in saying that asteroid color is 255, 255, and then we use asteroid color here. What else do we need? We need initial coordinates and final coordinates. So we need x0, y0, initial coordinates, x1, y1 are the final coordinates, and then we need a thickness, and I'm going to put a thickness of 2. That should be enough. Now, we have drawn all the segments except for the last one that goes from the last angle, the last point, to the first point. Right? I have put all the angles in consecutive points in the angles in the list, but not the one from the last to the first. That essentially closes the contour. So therefore, we're going to take this set of statements and I'm going to align it properly, and then I'm going to make x0 being 0, 0, and then this guy should be the last one, so -1, -1, right? And the interesting thing is now, is it from max to min or from min to max? And if you look carefully at the example that we showed, because we always have a odd number of angles inside, we will go from max to min. And we have to draw now the last line. And we're going to go exactly in the same way. Sorry. One thing I haven't done properly is that this pie game has to be inside. And now what we can do is actually copy this part and we should be ready to draw. All right, so let's create a number of missiles here. Right, so I'm just going to simply assume that what's wrong here? So invalid syntax, unknown, no quick fixes available. Unfortunately, I think no, this is good, sorry. Have I forgotten a bracket? Yes, I have forgotten a column here. That's why we have a little red mark over there. So well, one thing I would like to do is create, let's say, 5 asteroids. So I'm going to say create asteroid, and we're going to get the ship position here for I. For actually, we don't care about I. For something in range of 0 to 5, right? 5 asteroids should be enough to show us that the whole thing works. Actually, not in missiles. Missiles is the wrong place to put it. Let's take this out. And then we're going to put here asteroids. Alright, so this is for test. We're going to remove it later. And another thing we need to do inside now is, after we've rendered the missiles, before rendering the missiles, because actually the missiles are small, the asteroids are big, are large, so we don't want the asteroids to wipe out, to make the missiles not visible, right? So actually we're going to draw the asteroids even before drawing the ship. So we're going to say for AST in asteroids, right? And what we're going to do is draw asteroid AST. And this should, in principle, work. Let's see if this works. Okay, so we have a bunch of asteroids, and we don't have collisions yet. All right. One thing we want to do, I think, is fix the asteroids are not completely closed, and that, I think, comes from the fact that we have used a number of samples of 1 to 100. If I say 101 here, no, then it should be 99, which is 33 of them. So we're picking 33 samples from a range of 1 to 100. If I'm going to pick 32, does that close everything? It seems to be closing down, just that the first and last are incorrect. So in order to draw them properly, right, actually I have to change the angle. So this should be -1 and 0 and 0. All right, so now we have five properly drawn asteroids. All right, this is wonderful. Then another thing that we want to do is, as we render them, we want each asteroid to move a little bit, all right, and rotate a little bit. So we're going to have an asteroid rotation speed, which is going to be something like pi. Everything has to go relatively slowly, right? So pi over 30, something like that. That's good. All right. So as we did before, after we put the asteroids on the screen, or as we put the asteroids on the screen, for each asteroid we compute the new position. So we're going to have a new list, new asteroids. All right, which is an empty list. All right, and then for every asteroid, I'm going to produce a new piece of data, NA, which is going to be, let's say, so from the asteroid, let's again get all the data, and I'm just going to do that by copying this line. All right, and then for the position, we're going to have x and y equals pos. All right, and then the new asteroid will have a new position which is dependent on this velocity, right? This velocity always will remain the same, and also it will depend on this direction. So I'm going to have new asteroid, or we're going to start with new x, xn, x new is x plus right, velocity times cos direction. All right, and then yn is y plus velocity times sine. Direction never changes, velocity never changes, right? The rotation nevertheless, new rotation, or rotation new, is the old rotation, rot, plus asteroid rotation. And then we're going to have that if this position, new position that we're developing is still on the screen, All right, so if we have that if x0 less than equal to x less than width and 0 less than equal y less than height, right? And it means that the asteroid is and actually the asteroid is still visible as long as it might be partially visible, right? So we should include the radius here. So we should say minus the radius was, I think, did we say 40 and 50? 40 and 50, right? So is as much as 50. So minus 50 is less than x less than width plus 50, and minus 50 less than y less than height plus 50 then means that the asteroid is still visible. So the new position of the asteroid, not x, but rather xn and yn, right? And if it is still visible, we can keep having it on the screen, keep rendering it. So new asteroids.append, and here we're going to have xn, yn, and then further we're going to have the rotation, which is Rn, and then the angle stays the same, the velocity stays the same, and the direction stays the same. All right, so we have added the new shape of the asteroid, the new state of the asteroid, to the new list of asteroids. And finally, once we're done with all the asteroids, we can update the full list. So we can say the asteroids list is updated to the new asteroids. Okay, so now we should see asteroids moving and rotating. And they're rotating too fast. And they're all right, so there's no collision currently, and they're all slowly disappearing from the screen. Okay, so we want to do a few things. One is asteroid rotation is too fast. So let's put it pi over 120. Then the velocity is too high, and I think we said that velocity needs to be an integer, but in fact it doesn't. We are not drawing any circles, so even though there's an underlying circle there, so having the velocity as being 2 times random is too high. So actually I'm going to say 0.5 times random, and let's see how it works now. Okay, much better. So currently there's no collision, and the next thing that we're going to have to figure out is what happens with the collision. Alright, every time an asteroid is killed, we're going to figure out how to spawn more asteroids. All right, so we'll stop here the current recording, and the next thing that we talk about is collisions. So the next thing is to detect collisions, right? If you remember from your geometry, the distance between two positions is the square root of the sum of the squares of um, the the coordinate vector, right? So if I have two positions, P1 and P2, with x1, y1 being P1 and x2, y2 being P2, right? The distance is going to be the square root of well, let's for simplicity, let's do dx equals x1 minus x2. We don't care whether it's positive or negative, right? Dy equals y1 minus y2. We don't care whether it's positive or negative because we will square it. And then sqrt dx square plus dy square. So this would be the distance, all right? And as long as the distance is smaller than the radii of two objects, the sum of the radii of two objects, it means that those objects are colliding, right? So that's a very simple thing. Now, what do we do when two objects are colliding? Well, if the asteroid is colliding on a missile, or the missile is colliding on an asteroid, then the asteroid should disappear, right? We're going to do this in two stages. First, we're going to just make it disappear, but then we're going to put an explosion at the side of the asteroid, which will be displayed for a while. Let's see. We have two types of collisions, right? Asteroid colliding on a missile, or missile colliding on an asteroid, and then the ship colliding on an asteroid. Ship colliding on an asteroid, in our version, will very abruptly end the game, and the homework will ask you to do something more sophisticated. Let's do that. So for every missile, we could check whether it collides with an asteroid, but actually it's easier to check whether every asteroid is colliding with a missile, as a matter of fact, right? So here we have the current asteroid, right? And if the current asteroid is colliding, then we don't add it to the new position. So let's see. We're going to have that or is collision is going to be equal to the dist all right, we start with this collision equal to false, and then we're going to iterate, right? So for missiles in missiles, right? So the missile will have a position and a direction. We don't really care about the direction. So we're going to have P, and I don't care. We get it from the missile. And then I'm going to have mx, my extracted from P. Let's call this MP to avoid any kind of confusion, right? So this is the missile position, and we have an mx and an my, and then we're going to have that if the distance between actually I don't need mx and y, distance between MP and POS, right? So distance between the missile and the position is smaller than, and we should use the outer or maybe the inner radius of the asteroid, so maybe less than 40. Then there is a collision, right? So we can say that is collision is true. All right. And we can also say break. We don't need to continue. All right. So if this is happening, if we have a collision, then we don't need to add the asteroid to the list of 2 asteroids. So, and not is collision. All right. So this asteroid can be put here if there isn't a collision. So let's see this working. All right. We have the, and you can see how whenever we hit the asteroid, it's kind of a bit slow. All right. So now every time we hit an asteroid, the distance needs to be too small. So let's try to correct that. So when the distance is less than 50, so it takes quite a while to see it. Let's say 60 here. I'm not quite sure why, but okay, this one seems better. Alright, so it seems that 60 is gives a better illusion of collision. Alright, so this solves the collision. If there's a collision between the spaceship and the asteroid, then we just end the game. Alright, so another thing that we want to do is before anything is done, right, just check collisions with the ship. So we're going to say if dist between the ship position and the current POS is less than, right? And here, what should we consider? We should consider the radius of the ship, which is about 40, I think. All right, let's go back and check. Radius of 40 and the radius of 50 of the outer circle. So if this distance is less than 90, right, we simply exit. So we're not going to do anything sophisticated. This is going to be part of your homework to do something more sophisticated. So we have to perform exactly these two actions. And you don't have to understand fully why, you have to just do it. So let's see now that the asteroid collision is done correctly, right? So the 90 that we have chosen is probably too harsh. So let's write here something like 70. All right, so every time we see a collision, the game terminates abruptly. All right, so we can stop here for the time being. And next time we can talk about the explosion, and we can talk about what happens if an asteroid is killed. Should we spawn more asteroids? And to keep the game fun, the answer, of course, should be yes. So let's stop this current recording, and then the next one will talk about explosions. So one thing that we want to do next is replenish the asteroids, not let the asteroids go to zero. So every time we destroy an asteroid, we would like to create a new one, right? So if we decided that we have a collision, all right, we will remove the current asteroid from the list, all right, and we will create an asteroid there. So the asteroids list will gain a new asteroid. So we're going to say if there was a collision, let's see, if is collision, then we're going to say asteroids dot append create asteroid, and we want to pass in the ship position. Okay, so that will keep us with a number of 5 asteroids. Let's see if that works. Yeah, you see it works fine. Every time we remove an asteroid, well, actually every second time, it seems. So something is wrong about creating a new asteroid. So let's see exactly why that is. Well, perhaps it's better if we take this if statement and we put it inside here. Control V. And instead of doing it on asteroids, we can do it on new asteroids. And that will solve the issue. So again, let's test this. Every time we destroy an asteroid, we create a new one. Asteroids unfortunately can disappear simply because they move off the screen. Alright, so this seems to work fine. Again, we want to be sure that we can stop the game when we clash into or crash into an asteroid. We crash the ship into an asteroid, right? The next thing that we want to add is explosions, right? We can have many asteroids exploding as a result of the missile, right? And the explosion is just another object, but it's an object with a limited life. All right, so in drawing we want to draw an explosion, right? So draw def. And we want to draw the explosion at a certain position. All right, so we're going to do a similar approach to the one we did for the thrust, right? To show thrust, we draw something like a flame. We take the same approach, but we take the area of displaying random circles as a bigger circle, pretty much of the size of the asteroid, right? And we will replace the asteroid by the explosion. Let's see how this goes, and then the explosion will have a certain life. Let's say maybe something like 10 seconds, so 200 frames, something like that. And okay, let's see how this is done. So we're going to draw 10 random circles. I'm going to steal some code, right? So we're going to draw a number of random circles, all right, of random colors at a given position. So I'm going to steal this code. Right? So for a number of times, maybe this number should be a bit larger. So I'm going to make it maybe 30. All right, I'm going to have a position which is xy. All right, and we're going to have the explosion radius equal to 50, about the same size as the um, outer asteroid. And then for 30 times, right, we're going to do this 30 times, I am going to create a position, right? So that position is a random radius from the circle, right? So I'm going to take the explosion radius here, and actually explosion radius, and I'm going to multiply it by random. All right, and then I'm going to pick a random color, and then I'm going to create a random angle, right? And this angle is actually between 0 and 2 pi, so we don't have to be very complicated. Previously we were supposed to be confined under a very strict area behind the ship. Nevertheless, now we are inside a full disk. So a full disk has an angle of 2 times pi times random, right? And then we're going to say the x for explosion is the center x plus the r times cos A. The y for explosion is, so this is one circle, right? Y plus r times sine A. And then we can very nicely say xe, ye, and I'm going to make the disk for the explosion potentially larger. I'm going to go up to 7. We're going to want larger disks. All right, so we're going to have, as we had before, we're going to have a list of explosions. Which is initially empty. All right, we're going to have an explosion time, which is going to be maybe 200 frames. All right, and then we have to render the explosions. So whenever we encounter a collision, all right, we create an asteroid, right? And we also create an explosion at the old place of the asteroid, right? So at xy. So we're going to say explosions dot append, right? And what we put in that explosion is actually a pair between the pos position and the lifetime, which is explosion time. All right, so that means that in that list there's a new explosion. So then we're going to get to the point where we render the explosions, and we're going to render the explosions when we get that point, and then that explosion will be rendered. All right, so this is the place where we render the explosions. For explosion in explosions. All right, so what do we do, right? We have a position and a time equal to explosion. All right, And now, if the time is greater than 0, right, we're going to draw explosion at position P, and we're going to put back. So obviously, we're going to take the same approach. We're going to say new explosions is the empty list. We're going to put in the new explosions. The same position, because the explosion doesn't move, but t minus 1, right? So we have 1 unit of the life of the explosion has elapsed. All right, and then at the end, explosions becomes equal to new explosions. All right, so let's see if this works. Okay, so we see that the explosion is a bit too long. So we're going to make it shorter. Okay, so let's make the explosion a bit shorter. So how about we just say 50? Still too long, so maybe 20 is just enough. So we can kill 3 asteroids in 1 shot. Okay, something like this. So maybe 20 is better. I think even less, even shorter would be even a bit better. Let's say 10. Obviously, you can create more compelling animations. We can do something like this. Probably try doing a better job at putting the asteroids closer to the center. Even though we want them far from the ship, we want them close to, not that far, that close to the edges. Another thing that could be interesting is to spawn more asteroids. Once you can kill 1, for instance, spawn 2. Right, so the number of asteroids would constantly increase. Anyway, so this settles the explosions, right? Another thing that would be interesting is to have an explosion when the ship collides, right? So we're going to do that by, let's see, collision for the ship. Right, so if we so if we collide, actually, let's create a explosion here. So instead of quitting, right, what we want is explosions, sorry, dot append, and we want the ship position, pause, ship position, and we're going to give it a longer time this time, right? So maybe for the ship we want a longer time, something like 200 maybe. Now, how do we get the game to stop? All right. So what's going to happen is that we will continue to be in this loop and discover the fact that there has been a collision. So we might actually do a much simpler thing. Say here at the top we can create a flag saying game over, and we can set this to false. All right, and then here, this while loop, we can say if not, game over. All right, which makes sense. We are going to play for as long as the game is not over, and the the one thing we do here is where is it? Yes, here we say that the game is over. Equals true. Right now we want to have a countdown. So before the game is over, right? So let's say we give it a countdown. So game over count down equals, let's say, 200, and then we're going to say if not game over, or if game over countdown is greater than 0, right, then we do this. And then one thing that we can do immediately, we say if game over, I can decrease the game over countdown, right? So game over countdown minus equals 1. All right, so this will ensure that the game eventually stops, right? So we're going to get the game to stop but still display the last explosion of the ship for 200 frames, which is a long time, and then it will simply stop. Okay, so if I go and crash, now there's a big explosion and game ends. However, we don't want the ship to keep moving once it has um, stopped, once the game is over, right? So um, let's protect the ship movement, right? Let's protect the whole ship movement by um, the game over flag. So we're going to say if not game over, right? So if it's not game over, then we move the ship. Otherwise, we do not move the ship. So this will make it okay, right? So the ship does not move anymore, and you can see that we can, because we create new explosions every time, it becomes a much more intense explosion over time. With a lot more bubbles. So this would be, the game. This is the entire game. You can tweak it. Obviously, um, it's a bit maybe too slow and it's not overly challenging, but you have a base from which you can build more stuff now. Tweak it so it becomes more enjoyable. There will be one piece of homework that will be based on this game. Um, and do be aware of the fact that each rendition of the game is slightly different from the ones in the previous semester. So if you take the homework of previous of students in the previous versions of this course, I will know, because you will not be applying the changes to the current version of the game, but to their version of the game. So there will be slight differences, but still noticeable enough to me, so I will know that you haven't solved the homework alone. Be aware of that, please.